Hello everyone, welcome to Explorer Hub. In today's work example, we'll be finding the maximum error if we estimate cost of 0.15 pi using the first four terms of the Maclaurin series of cos x. So let's start. We know that if E is the error, then using Lagrange error bound, we can tell that the absolute value of E or the absolute error is less than equal to m absolute value of x minus a to the power of n plus 1 over n plus 1 factorial. So in this case so first of all x is the value which we are trying to find out, which is in this case 0.15 pi. A is where the series has been centered, which in the case of Maclaurin series is always 0, because we know Maclaurin series is the Taylor series which is centered at x equals to 0. So a in this case would be 0, and n is basically the maximum number of terms that we are using from the series to estimate the value that we want. So as I said, x in this case would be 0.15 pi, a would be equal to 0 because Maclaurin series is always centered at 0, and we know that n is equals to 4 since we are using the first four terms of the Maclaurin series. And now for m is basically the upper bound of the n plus 1 derivative of the function that we are using. So in this case we are using cos x, so m would be the upper bound of the fifth derivative of cos. Upper bound means the maximum value that the fifth derivative of cos x can have. So the first thing that you can do is that we can either make a table and find the fifth derivative of cos x. We can differentiate cos x 5 times and see what's the final differential that we're gonna get. Or the other thing is, and in that case, if we just move with it, then we know that if you'll differentiate this 5 times, you will be getting minus sine x. So d5 dx5 cos x is equals to minus sine x. You can differentiate cos x 5 times and you're gonna get minus sine x. So this is one way of doing it, and you know that sine x has the upper bound of 1. That minus sine x has the lower bound of 1, and minus sine x has the upper bound of 1. So as a result, we know that the m would be equal to 1. So the other thing that we can do is the other way we can avoid doing this, differentiating cos x 5 times to find that. We know that cos x is a trigonometric function, and we know that the derivative of the cos x is always sine x, and the derivative of sine x is always cos x. So whenever we will differentiate cos x as many times as we want, it's always going to alternate between cos x and sine x. So irrespective of what the fifth derivative of cos x is, we know it would either be cos x or it would either be sine x, plus minus sine x, either one. So nevertheless, we would know right away that the upper bound of the fifth derivative of cos x would be 1 without even figuring out that the fifth derivative is minus sine x. So we can directly write that m is equals to 1. It saves us some time. So anyways, moving on. Now we have all the values. We'll just substitute them in this Lagrange error bound, and we would get E to be less than equal to 1, absolute value of 0.15 pi to the power of 5 over 5 factorial, which if we use a calculator to find out would be 0.00194. So the question asked us to find the maximum error. So we know that E is less than equal to, the absolute value of E is less than equal to 0.000194. So the maximum error is equals to 0.000194. So that was all. Thank you for joining us. I'll see you all in the next video.